Hello everyone, welcome back to another session for Applied Thermodynamics. Today we are going to continue our discussion about chapter 4 or the properties of the air or standard air. In previous sessions, I told you some properties of the standard air and I told you why these properties are important like humidity, specific humidity, relative humidity, wet bulb temperature of the air, and also dry bulb temperature of the air. Today we are going to continue those discussion and also I'm going to tell you and show you why those properties are important. But before we go further and show you how we can use those properties to evaluate, to design a air conditioning system, we need to understand how we can find those properties for in different condition and situation. As you know, as I told you before, we have some equation which we can calculate these properties. But if we can have a method, if we can have a chart actually to find these properties, it will be much easier. Like the tables which we have for thermodynamic properties of different substances. Here also, if we can have a chart which we can find those properties which I already told you, we can find those properties on that chart. The our calculation or the evaluation of different AC uh, system will be much easier. This chart, which shows the different properties of the standard air, is called psychrometric chart, and it is very important chart, especially in air conditioning application, and it is actually outcome of experiment during last 100 years, and this chart is very famous in HVAC industry as well. So let me show you what are the properties of this table. The psychrometric chart is, the actual psychrometric chart is something like this, which is the figure, as a figure, it is presented as a figure in your textbook, and you can find it for uh, air in 1 atmosphere pressure. You need to know that as well, this graph or this chart is presented and need to be presented for different pressure. So what we have here is for 1 atmosphere pressure. Now let's see how we what we have in this chart and how we can use this chart actually. As I told you, this chart is important because if we have just two properties, we can find the other properties of standard A. The properties which we can find in this chart are specific humidity. I hope you already know the definition and explanation of each one of these properties. We have specific humidity on the right side vertical axis of this chart. We have dry bulb temperature and other properties on the horizontal axis of this chart. We have saturation line, which is a curve at the left hand side of the chart. As you know, based on the definition, saturation line is the properties of the air which contain 100% of possible air moisture or water. And also we can find relative humidity in this chart. We can find V or specific volume of the air, and we can find enthalpy and also dew point temperature of the air in this chart. So you can see here we have 1, 2, 3, 4, 5, 6, 7 different properties in this chart. And if we just know two properties of the substance, two properties of the air, we can use this chart to find the other properties in this chart as well. Have a better understanding of this chart. Let me show you the actual chart. This you can see here in the actual chart what I told you we have in this chart. We have dry bulb temperature here on the horizontal axis in terms of degrees Celsius. We have humidity ratio, or omega, if you remember, which is specific humidity as well, we call that. Here the units for this property is grams moisture per kilogram dry air, which means water or H2O. This is omega, so we can find omega on this line. You can see different unit for that: 2, 4, 6, 8, and until 30. And we have also enthalpy. You can see here, this is the line of enthalpy, the number for enthalpy per kilogram dry air, or H, we can find on this line. We have saturation temperature. You can see this line, the last curve on the left hand side of the this chart is saturation temperature in terms of degree Celsius. And you can see also this line, this color for the uh, pink color almost. You can see the on this line we have uh, in this line we have relative humidity, as also is mentioned here. Phi, these lines shows relative humidity, these lines. And also, you if you notice, we have this volume cubic meter per kilogram dry air. This is the specific volume as well, per as as you know, and as I told you before in previous session, the properties, the specific properties which we defined here, if you remember, for different substances we had enthalpy, specific volume, even internal energy, and so on, based on the, based on, for example, H was H enthalpy divided by mass of the substance. But as I told you in previous sessions, for standard air here, because the mass of the dry air is constant and it doesn't change with the change in the temperature, the moisture content of the air, we have this specific enthalpy based on the kilogram of dry air, not kilogram of air. So this is the difference between the enthalpy which we have here in this chart, and also the enthalpy which we usually use in our calculation. So we will see an example to show how we can use this chart to find the different properties of standard air when we have just information about two different properties. Moreover, we have some interesting properties for saturated air on this chart. For saturated air, as you know, the dry bulb, wet bulb, and dew point temperature are identical. You know these from previous session. So the dew point temperature of atmospheric air at any point on the chart can be determined by drawing a horizontal line. This is actually the procedure which we will use in next of this chapter as well, to find the relative humidity and so on. So here the dew point temperature of atmospheric air at any point on chart can be determined by drawing a horizontal line, like what you can see here, a line of omega as a specific humidity, or PV, or water vapor pressure constant, from the point to the saturated curve. So if we know the dew point temperature, if we want to find dew point temperature of atmospheric air at any point on the chart, we just simply uh, from the point which shows its specific humidity, we can draw a horizontal line. Once it reaches the saturation line, that the temperature on this saturation line, if you notice here in the chart, we have saturation temperature. So if we draw a horizontal line from any point of these, first of all, it shows what is the specific humidity on the this vertical axis, and once it reaches this uh, line, this curve, which is saturation temperature, that temperature will be dew point temperature. So this is the way we can find dew point temperature for this case. And also, it is mentioned here the temperature value at the intersection point is the dew point temperature, like what we have here. This, we have a specific humidity here. This is horizontal line, and here we can find uh, the dew point temperature, which is on saturation line. And also, this chart can be served as a valuable aid in visualizing the air conditioning process. How? You know, once we are using air conditioner, we will change its temperature, and also sometimes, the change in the temperature sometimes may cause the change in its humidity as well, but not always. So in the rest of this chapter, we will see different type of the air conditioning system, and you will see in some of them we need to humidate or dehumidate the air in the air conditioning system. If we don't add any humidity or water, or if we do not absorb any humidity from the air which is go through the air conditioning system, then its humidity, the omega or a specific humidity remain constant. Then its process will be a line like this. This is omega constant line. So it will be like this. So this will help us to see in an air conditioning system we have humidation or dehumidation process or not. So an ordinary heating or cooling process change only in the temperature of the air, for example, appear as a horizontal line on this chart if no humidation or humidification or dehumidification is involved, like what you can see here. A horizontal line, omega doesn't change. Any deviation from this horizontal line indicates that moisture is added or removed from the air during this air conditioning process. We will see in some example, and also once I introduce you different type of air conditioning system, you will see how the graph, here this chart shows the properties of air at 1 atmosphere pressure. So once we have air conditioning system on the and pressure remain constant during that process, that air conditioning process in what atmosphere, we can use this chart. For example, we have also chart for the other pressures, but what we have here in our textbook is one for 1 atmosphere pressure. So we can use this chart to see how properties of the air is changed in that air conditioning system. And here we have an example of how we can see the properties of air is changing in air conditioning system, and this psychrometry chart will help us a lot. So we have an example to show how we can use this psychrometric chart, and in the rest of the chapter we will use this chart to find different properties of the air. Okay, you have seen what is the psychrometric chart. Now we have an example here to see how we can use that chart to find different properties of the air. So in this example, we have a room which contains air with 1 atmosphere pressure. Its temperature of the air inside the room is 35 degrees Celsius, and its relative humidity is 40%. This is the property of the air which we have. Now, using the psychrometric chart, we need to determine these properties: the specific humidity or omega, enthalpy or H, the wet bulb temperature or TWB, and the dew point temperature or TDP, and also the specific volume of the air. First of all, you know that, as I told you, we need to check the pressure. The pressure of the air, which is mentioned here, is 1 atmosphere. So we can understand that the chart which I showed you, and also you can find in your textbook, can be used here in this example. However, it is mentioned here, but you need to check if pressure is 1 atmosphere or not. And also, you need to notice if we have enough information to use a psychrometric chart. As I told you before, we need to know at least two properties of the air to find the other properties. As you notice here, we have temperature of the air and also relative humidity. So this temperature, 35 degrees Celsius, of the temperature of the air is a dry bulb temperature of the air. And also the relative humidity, which is mentioned here, is 5. So we have 5 and we have TDB or dry bulb temperature of the air. So we can use these two information to find the other properties, which is question, which we need to find in this question. So let's go to the answer to see how we can find these properties on psychrometric chart. Okay, now as you can see in this slide, we came to the psychrometric chart to see how we can use these chart to find the properties in the question. Okay, first of all, let's see what we have. We have this temperature. The pressure is the pressure which we need to have to be able to use this psychrometric chart in our textbook. So 1 atmosphere, first criteria is satisfied. Temperature, 35 degrees Celsius. This temperature is dry bulb temperature, the temperature which we can directly measure by a thermometer. Temperature is 35 degrees Celsius. Let's locate that on our psychrometric chart. If, as you know, on the psychrometric chart, the horizontal axis shows dry bulb temperature. So the temperature which we have here is 35 degrees Celsius. Okay, let's see. The temperature which we have on the psychrometric chart actually is from 0 to 50 degrees Celsius. Our psychrometric chart, because these usually the temperature of the air which we need to use air conditioning system is in this range. So our temperature is 35 degrees Celsius. Okay, 0, 10, 20, 30, here is 40. So this point which is between them is our dry bulb temperature, 35 degrees Celsius. So this line shows our dry bulb temperature. How about the relative humidity or phi? It is 40%. Okay, which one of the lines in this chart shows relative humidity? If you notice here, it is mentioned as well, these lines, these parallel lines, 10%, 20%, 30, 40, and so on, shows the relative humidity of the air on this psychrometric chart. Our relative humidity is 40%. So let's see, here is 10%, 20%, 30%, 40%. So this is our line. So by these two properties, we can find the place and locate our air with these properties, the air of the room, which is in the question on this chart. So we need to just find intersection for these two lines. So this is our line. This is for dry bulb temperature. This line. Uh, this line is our line. We draw that. You can see it should be actually a straight line, and this line also is the line of the relative humidity. Then the intersection is this point. And now by this, as I told you before, we can find the other properties. How we can find those properties? As you know, on this side, the right side of this chart, we have humidity ratio or a specific humidity omega in terms of gram per gram of moisture per kilogram dry air. So first of all, the first part of question was about omega or relative or humidity ratio. So what we need to do is to draw a horizontal line from this point until it again intersect, this line, this humidity ratio or omega line. If you notice, it is between, well above the or close to 14. 14 gram of H2O per kilogram of dry air. So you can see here we found that omega is 0.0142 or 14.2. What we found in the table was 14 something, which we can say 2. It is close to 14. Okay, but it is gram H2O moisture divided by kilogram of air or dry air. So to convert it to kilogram of H2, simply we can divide it by 1000. So omega or specific humidity in terms of kilogram of H2O per kilogram dry air is 0.142 kilogram H2 per kilogram dry air. So simply we can find omega by this line. Okay, the next part is we need to find enthalpy. Okay, where is enthalpy on this chart? Again, our point is here. Do not forget our air. The location of our air in this chart is here. So to find enthalpy as is in on this line. This is enthalpy in terms of kilojoules per kilogram dry air. So these lines, this line which comes from the left hand side to right side is enthalpy. So you can see here this one is 70. So this is above that. Here we have 70. Here we have 80. So each one of these spaces, one, 8, 9, and 10. So each one of them is 5. Each one of these units. What we have here is well on these. So it is a 71 actually. So our enthalpy here also is 71.5, a little above this line. So our enthalpy, this amount of accuracy also is acceptable. If you just look at 75, 71 also is acceptable. Depends on the how much is the quality of the chart which you have, and then you can locate these properties much easier. So this is the line which we have for enthalpy. And what is the next property? It is with bulb temperature. Okay, what are with bulb temperature? If you notice, with bulb temperature are these dashed line. It is not that much clear, but you can still those line, these line which are parallel to the enthalpy, but they are shown by these dash line. So here this dash line is 25 degrees Celsius, and this dash line, which is closer to our line, let's see, this one is 20 degree. No, this one is 20. This one is 25, and you can see our line is closer to 25. So it will be 24 something. It is not that much clear, but we can still locate that. So the temperature of wet bulb temperature is 24, for example, 1 or 24. You can see wet bulb temperature also is 24 degree Celsius. How about the next property which we need to find? It is dew point temperature. So let's see where is this dew point temperature. Dew point temperature, as we mentioned earlier, we need to draw a horizontal line until it touches the saturation temperature line. So to find that, we need to draw this line until it reaches this line. Again, it is you know this point is 20 degrees Celsius, so it is less than that, and this point is 15 degrees Celsius. So our temperature is less than this temperature. It is 15, 16, 17, 18, 19 something. So 19.1, for example, temperature of or uh, uh, to be more specific, it is 19.4 degrees Celsius. But if you just locate 19 something, 19.1 for example, it is still acceptable. And so this horizontal line until it touches the saturation line shows dew point temperature. What about the next property? It is specific volume of the air. Okay, which line in this chart shows the specific volume per kilogram dry air. If you notice, these lines show the specific volume. Okay, let's see where uh, is the our state and how much is the uh, specific volume for that. If you notice here, we need to understand how much is this specific volume. This one is 0.92, and here is 0.90. Here is not mentioned on this line, which is close. Our line is here. Here is 0.88. Here is 0.90. We need to just count this. This is between these two, and our point is a little higher than this. So we can say this is uh, between these two, 90 and 0.88. To be more specific, its value is 0.89. The amount of the specific volume, 88, 89 here almost, and here is 0.90, the volume, the specific volume or cubic per its unit is cubic meter per kilogram dry air. So you have seen how we can find all of these properties, by this psychrometric chart. And you can see also this graph which shows this procedure. The first of all, this show how we draw this graph. First, we found these two properties, we found the intersection of those properties, then start to draw some horizontal or some other line to find the other properties. Omega here, TDP at the left side, and enthalpy, and also TWP, V also. So we found all of these properties by this psychrometric chart. And you have seen also how much the quality of the chart is important. Here I just copied and paste from the textbook. So usually we have this chart on a in a good size, and for example an A3 size, and with high quality, then you can locate these properties on this chart much easier than what I have done here. But the procedure, I hope you have already got familiar with that. The procedure which you can use to find different properties on this psychrometric chart.